Just how many? When? 5. Oh, what did it say? I think that's Man City. They came to Premier League in 2000. Okay, let's discuss this question. So just in case you don't know, we are done with the equations of circular motion. These are the ones that you have. So you have 4 main equations out there. There's angular speed, velocity. It's also called tangential velocity, centripetal acceleration, and centripetal force. Using these 4 equations, you can actually solve any question out there in circular motion. And you need to know the derivation of this one, which we derived the other day. So yeah, these are the equations. Now we need to learn how to apply them in questions. And the questions do get very tricky. So we'll spend some time trying to figure out how can the questions be framed. Okay, so the first thing is, this is a very basic question, just to get a hang of the equations. It says a fan blade has a spider on top of it, and friction between the spider's legs and the blade is so it says that the friction between the spider's legs and the blades is 3 Newton. The spider is located 1.2 meters from the center of rotation. Find the maximum rate at which the spider can spin so that the spider doesn't fall. The fan can spin. Provide the answer in rotations per minute. Mass is provided. So what's this question tell us? So it basically tells us that there's this fan blade, and this blade is going to rotate like this. So it's rotating like that. And on the top of the blade, there's a spider out there. And apparently, there's a particular velocity or speed or rate of rotation at which the spider will fall from the blade. So you need to find out at what rate should this be moving so that the spider falls off. So how do we do this question? So first question, what's keeping the spider from falling off normally? So I give you an example the other day. So if you have this scale here, and if you place like a eraser here, and if I move it very slowly, it stays, right? And as I start to go faster, it will still stay, but there's a point where it'll fall. And is it falling when I'm very slow or very fast? Yeah, so if I move very fast, you notice it starts to fall, right? So it means that speed is the factor that eventually causes the fall, right? So you need to figure out what is the maximum rate or speed at which you can move till the spider falls off. So like, what's the capacity, right? Towards the center, right? So let's try to understand what's keeping the spider in circular motion to begin with. So if you look at the side view here, let's say this is the spider there, this is side view, okay? when the blade is rotating, which way is the spider naturally trying to move? Is the spider naturally trying to move in a circle, or is the spider naturally trying to move in a straight line? Straight line, right? So if you draw a circle here, এটা যদি follow করো, you'll find that the spider is actually trying to go this way. So that's because of what law? Why does the spider try to go straight? It's because of first law, right? And this is the what velocity of the spider? The tangential velocity, right? So basically inertia takes it forwards. However, as the spider starts to go outwards, right? It is spider the spider on the blade, right? It's trying to actually go outwards. Why is it trying to go outwards? Because it's supposed to follow that path. Which way is the blade moving? Is the blade also moving outwards, or is the blade moving inwards? Yeah, the blade is moving inwards, right? So as the blade tries to move inwards, it pushes the spider inwards. And that's the friction that keeps it inwards. So essentially what's happening is the spider is trying to move out. And why is it trying to move out? Because it tries to maintain its path. But as it tries to move out, there's friction on the floor, right? So friction pushes it which way? Back in. So for example, if I just keep the calculator on the table, right? Is there any friction? Yeah, so the friction will only start to show up when you try to what? Move, right? So as the blade rotates, the spider is actually trying to go which way? Away. As it tries to go away, it's trying to skid away. So as it tries to skid away, what does the blade do? Provide friction. And it turns out which way does it provide that? Towards the center. Okay. So yeah, the friction is the force that keeps the spider inward. So we wrote about this last class. Centripetal force is provided by friction. But my question is, why is there a limit to the rate of rotation? When the rate of rotation is a limit, right? Why is it so? What limits it? Okay, so turns out if your object is moving in a circle, look at this example, it's very straightforward. If there's no rotation, right, how much centripetal force do you need if there's no rotation? A equation দেখে তোমাদের easier হবে বলতে. Look at this equation here, F equals to m omega square r. If your rotation is 0, right, what is the force needed? 0. Nothing happens, it doesn't move and fall. Let's say you start to rotate. Wouldn't you need a force, right? So the force is there, so it's rotating very freely, no problem, right? As you start to go faster and faster, তোমার যত speed বাড়বে, এটা বাড়তে থাকবে, what will also start to increase? The force. Now, is it the force that you're providing that increases, or is it the force that you need that increases? There's a difference, okay? This F is actually not the force that you're providing. This is the force that's needed to be in a circle. So as you start to go faster and faster, don't you need more force to keep you in? And if you need more force to keep you in, who's going to provide that force? Friction. Does friction have infinite value here? No, right? Isn't there a limit to it? So once you go fast enough that your requirement is more than the friction can't keep it in anymore. So what does it do? It flies off. Okay? So the idea হচ্ছে আমার friction এখানে হচ্ছে 10 Newton. Our requirement হচ্ছে 4 Newton. Will it stay? My friction is 10 Newton, requirement is 4 Newton. Will it stay? Yes, because 4 Newton to দিতেই পারে. It's 9 Newton now, the requirement, right? And the friction is also 9 Newton. Will it stay? Yes. Just barely. But let's say your requirement is 10 and your friction is 9. Will it stay? No, তখন কি হবে? এটা slip করে পড়ে যাবে. Okay, so I'll give you something that makes, based on common sense. Let's say this surface here, right, is not smooth or polished or anything. It's a carpet. Like it's a very rough carpet here, okay? Do you think the spider will find it easier to stay on the carpet or on the polished surface? Carpet, right? If there was a carpet on the blade, wouldn't the spider more likely stay on the carpet than on a flat polished surface, right? Why is the carpet better? Yeah, it provides more friction, so you can actually go faster, right? Imagine there was glue here and the spider was stuck to the glue. Would it be easier or difficult than before? Even more easier, because the glue will provide extra force and that will keep you in. So the idea is, as you go faster and faster, you need someone to keep you in, and that something that keeps you in could be any force. It could be friction, it could be tension, it could be electrostatic force. In this particular scenario, what is the force that keeps you in? Friction, right? There's nothing else here. Now imagine this was a person. Okay, let's try to change the scenario. So it's spider turn, and it's a person standing here on this belt that's rotating. Okay, imagine there's this belt that's rotating here. What will keep the person on this thing as well as it rotates, right? What keeps the person on this thing? Friction between the floor and the person, right? But let's say it starts to spin very fast. what can the person do to keep himself on this thing? Yeah, you can lie down for like a friction or a barbell because there's more contact area out there. Or what if there's like a rope here and you're holding onto the rope? Would that keep you on the thing easily? Yes. Why? What would the rope provide on you? And that tension will help provide which force? Okay. So at the end of the day, if anything helps you provide a force towards the center, it can keep you in a circle. Okay. Unfortunately for the spider here, the only force we have is what? Friction. And that also has a limit here. How much is it? 3 Newton. So if you're trying to go in a circle where you need more than 3 Newton, what will the spider do? Fall off. So my question here was, how fast can you keep rotating the blade till the spider falls off? That's the question here, okay? So Kiki, answer to that if you have any answer. 677. 670 rotations per minute. Okay, your one was how much? 107. RQ. Try to that. This is as easy as it gets. Okay, so if you can't solve this, Oregolo obviously power eventually, but it's difficult of it. Round it down, because if you round it up, it means it's a faster rate. So it means the spider will definitely fall. 106. Okay, I'll solve one for you. We'll practice another question. So that will give me a quote if you don't know what to do here. So first thing is, we know 3 Newton is our requirement. Okay, so that's the first information we know, that 3 Newton is the maximum force out there. So what I'll do is, I'll use the formula for centripetal force, which is what? Fc equals to m omega square r. I'll use this formula, right? And I will see what's the maximum rate that comes out from here. I'll use what as the value for my centripetal force here? 3. Okay, so I'll write this down. Maximum centripetal force available is 3 Newton, provided by what? By friction, correct? By friction. So that's the piece of information that we have, that the maximum force available is that. Next is 3 there on math query. So 3 equals to mass of the spider was how much? 20 grams. So 20 divided by 1000, because we need it in SI, omega square, rotation Berger-General, into R. What was the radius? 1.2. So from here, you will get the value of omega. How much is the omega? 11.18. Right. So 11.18 unit. Right. Radian per second. So radian per second. The unit for angular speed is radian per second. But the question is not this. The question is how many rotations, right, per minute. How do you do that? Omega theke. So omega, can you break down? Can you tell me what's the formula for omega? 2 pi f or 2 pi by t. I mean 2 pi by t. I mean time to wait. So the time of oscillation here, or time of rotation, is going to be how much? 11.1. How much is the time for rotation here? So time to wait, 0.5. 562. Let me explain what we just found to screen it. So we found that the centripetal force is 3 Newton. At that rate, your omega is this. Omega is what? Angular speed. It means how much angle is covered every second. Okay, so that's 11.18 radians per second. Using this information, we found the time period. So I mean, very good to say this is the time period. Can time period very good to say? Question is that, right? Why did I suddenly go for time period? Time is the time taken for what rotation? 1 rotation. And I need the number of rotations in what time? 1 minute. Can I do unitary method? If 1 rotation takes X minutes, right? Then in 1 minute, how many rotations would be there? So I'm going for unitary method here. So if one rotation, you can do it in different ways as well. Only frequency বের করে করতে পারো। আচ্ছা, if one rotation takes 0.562 seconds, then how many rotations would be there in a minute, which is how many seconds? 60 seconds, right? And yeah, it's a very straightforward unitary method question. 60 divided by 0.562. Can you check what the value is? 106.76. Okay, 6.8 rotations per minute. If you write this answer and keep it in this way, it's still fine. The examiner will allow it because there's no requirement that rotations need to be complete. But it's a fractional rotation. I'm 106.8 rotations for it. So this is 106. One rotation would be 107, right? But it's 106.8, right? So that's 106 point that much in every minute, which is fine. Okay, so you don't need to round it up or down. However, there are questions where they'll say how many complete rotations are taken. And in that case, do you think the answer is going to be 107 or 106? Yeah, it'll be 106. Why? Because 107 to the lacko, isn't the spider already fallen off earlier? So that means it didn't complete that, right? So you have to go to the lower number. Okay, so for complete rotation, we need 107, sorry, 106. Right, so there you have it. This is the question. Examine, this would be around 6 marks. It'll break it down into parts. Done. Okay, so we will see more questions now. This is a very standard question. Anytime you have trouble with circular motion, right, try to solve this question because it covers the basics out there. So the main requirement that you need to understand from this question is the fact that centripetal force is actually a requirement, and you need to test if your system has that requirement fulfilled or not. If it's fulfilled, circular motion hobe. If it's not fulfilled, circular motion hobe na. That's how it is. Okay. Right. So now we'll see the different types of examples we have. Start with the easier one. Can you go to page 16? Conical pendulum. Page 16. So the place where Cambridge questions get challenging is here. I'll show you with an example right now. This is a question that's there in your past paper, okay? এখন questionটা বলি কি? It says a conical pendulum has a rope of 2 meters in length. There is a ball hanging from the mass of 400 grams. Conical pendulum is made to rotate at 30-degree angle from the vertical. Find the speed of the bob during rotation. Now, problem here is that the part that's circular motion is actually very manageable. But how to get to that point of circular motion, that's complicated. It requires mechanics that might be even AS level complicated. Okay, so what is a conical pendulum? Let's see here. I'll show you here and I'll show you an animation as well. I think I mentioned about conical pendulum. It's essentially you can have your regular pendulum here, which is just goes like that in one single plane. That's called a pendulum, right? Conical pendulum is when you do this. As you do this, right, isn't it undergoing circular motion at the base? It's undergoing circular motion, right? But do you see that if you look here, doesn't it form like a cone? That's what's called a conical pendulum. Okay, I'll show you an animation that'll be easier of it. So yeah, so do you see this? This is what you call a conical pendulum. I'll change the viewpoint. Right, so if you look at from the front on, like straight at it, right? This is actually a normal pendulum. They're going to look like a normal pendulum, right? But if you look at from a different angle, and I'll show you the other path. Yeah, so do you see how it's going in a circle at the bottom? This is called a conical pendulum, okay? There's another version of it. This is exactly the one we're doing right now. Okay, so do you see how it forms a circle at the bottom of the screen, right? But is it actually going around the actual center of the rope? No, right? The center of the rope is at the top. Isn't it making a circle at the bottom, right? So this is called a conical pendulum. You will find that as you change the speed, things happen. I have a question for you, and use your intuition to answer. Acha, like, what do you think would happen in real life? If I have a conical pendulum and I, spin it very slowly, it forms a conical pendulum. As I start to speed up, right, does it stay there or does it move? Where does it move? Yeah, that's a 4-mark question. Why does it go up? Okay, so we'll be doing that. That's actually a question they asked. Okay, so you speed বাড়াই দেই আমার এখানে just a second. Right, so as you go here, I think this is just one single speed possible. In the previous example, speed বাড়াই দিতে পারবো. Oh no, ওইটা মানে এটাকেই জোরে করা হবে। আমি মানে জিনিসটা actual speed বাড়াতে যাচ্ছি। Yeah, so if I increase the speed here, where's the speed? There at the bottom. It went too fast. So Jay, do you see how it's at the bottom right now? And as I start to speed up, it starts to go which way? Up, higher, higher. And turns out, if you make it go really fast, it'll become almost flat. And then it'll look like a blade of a fan. So Jay, for example, that, right? If I like spin it very slowly, right? So it'll just go in a circle like that. As I go faster and faster, doesn't it rise up, right? And very high speed, it becomes almost perfectly horizontal. So there's a word I use, almost perfectly horizontal. So it turns out, regardless of what speed you spin this at, right, it will never become what? Horizontal. Another 3-mark question, why? Okay, so these are what we're going to answer. All right, basically the concept use for চলে আসবে. But let's try to answer this question. So it says a conical pendulum has a rope of 2-meter length. So আমি draw করে বুঝাই কি হচ্ছে. That's the rope. There's a bob hanging with mass of 400 grams. So this is the bob of the pendulum. And what else information is provided here? The conical pendulum is made to rotate at 30-degree angle from the vertical. What does that information mean? 30 degree from the vertical. So it essentially means that this is the vertical, and it makes an angle of how much with the vertical here? 30-degree. Okay, that's the angle of rotation. Conical pendulum, this angle is the one that matters, 30-degree. Okay, and it makes a circle. So the circle is at the bottom here, horizontal circle. So this is the conical pendulum's path. Are you clear about so far? So what will happen is the conical pendulum is going to do this there, like that. It'll keep rotating like that, and here the rope rotates like that. So at the end of the day, if you look at it overall, it looks like it's forming a what? Cone. That's why it's called a conical pendulum, right? So that's the diagram that we have. This is the information provided. They have provided further information here, which is the length of the rope is how much? 2 meters. So this is 2 meters. And there's a bob hanging here whose mass is 400 grams. So 400 grams. Find the speed of the bob during rotation. So at what rate is this bob rotating? So do you guys have any ideas what to do here? What provides my centripetal force here? I'll give you a hint. There's a force in this rope, which is what? Tension. Do you think tension provides my centripetal force in this question? No, why not? Yeah, because the tension is acting towards that point. Is the bob going around in that circle? Is it doing that circular motion? No, right? Isn't the circle at the bottom here? And the centripetal force must act towards the center of your circle, not just any random circle. So the centripetal force must be acting here, like that. That is my centripetal force. But what is that force? You're going to force the So what could that be? Yes, exactly. So what you need to do here is you need to break down the tension into its components. So tension has two components here. One is a vertical component and the other one is horizontal. Do you remember components? So what would the vertical component here be? T cos theta, correct. And what would the horizontal component be? T times sine theta, right? So that is my centripetal force provided force here, T sine theta. So T sine theta provides your centripetal force. Now that you know your centripetal force, right? What can you do? You can find everything. I'm that once you figure out what your centripetal force is, right? All the equations open up, and eventually you can find whatever you need. Okay. So, to that, do you guys want to try it? Speed there are a few more steps you need to apply, but I have given you, I think, majority of the requirements. Find for me what the speed is. And this is the problem with questions in your past paper. They'll be of this category, right? And you think it's just circular motion, but you need to know a lot of mechanics for it. So mechanics related on a question, Ashay. 3 pi, 3.4. Is there nothing written there? No, I mean, after page 12 is 36. Really? Oh. Page 12 and 36. What's on page 36? Some other chapter? Review questions from circular motion. No. Can I see the book cover? And this is the new one. Do you have this question in the review question? Same book. Oh, okay. What's the question on page 36? Oh, no, it's in a different chapter. Yeah, that's gravitational field. Okay, I mean, usually there are other copies that change to it. Yeah. Ashiyan Garu. Yeah, that's an important question. In your exam in Cambridge, when they say speed, they only mean tangential. And if it's angular speed, they'll say angular. আচ্ছা আসলে চেঞ্জ করে নিও because অন্য জায়গায় গেলে প্রবলেম হতে পারে. Did you take the book today? I think there are new books here. .76. You got the same answer. What did you get? 2.214. এখানে একটা চ্যালেঞ্জ আছে. The challenge is what's tension. Because you need tension, right? Tension বের করে তো answer বের করতে হয়. Did you find tension? Tension. আচ্ছা অসুবিধা নেই, করে দিই। আচ্ছা করি। Let me start. How much? Yeah, that's the answer. Okay, very good. So আমি বলি কি করতে হবে, সবাই একটু এদিকে দেখো। I need my force here, centripetal force, to solve this question. Unfortunately, I do not know what the tension. So the first thing is we need to find tension. How can we find tension? এটা হচ্ছে classic AS question. Resolving components vertically. So আমি vertically যদি component গুলোকে check করি, vertically, do you think this bob is moving up, down, or it's at the same level? Same level, right? When it's spinning, right, the bob stays at the same height. It shouldn't though, because what's acting downwards? Weight, right? So if it's trying to move downwards, right, and if it stays in its position, there must be what acting on it? An equal and opposite force which way? Upwards. So এই ববের মধ্যে তোমার নিচের দিকে যে ফোর্স অ্যাক্ট করতেছে, the force that's acting downwards is the what of the bob? The weight. W equals to mg. And what's the force that's keeping it from falling down? The vertical force, which is what? T cos theta. Do you understand? That's what's keeping the equilibrium. When আমার জিনিসটা যখন spin করতেছে, it's maintaining a constant height here. So it can't though, because weight is acting. Shouldn't it keep going back down all the time, right? But it stays at a constant height. How is it possible? The vertical component of tension is equated by what? Weight, right? So therefore, resolving components vertically, T cos theta must be equal to what? Mg. Do you agree? So therefore, T should be equal to what? Mg divided by cos theta. I'll show you an interesting derivation here. Derivation the কাজে দেয়, সবাই স্ক্রিনে দেখো, পরে কপি করো। T equals to mg divided by cos theta. Now, resolving horizontally, what can I find? The centripetal force, right? So resolving horizontally, centripetal force must be equal to what? T sin theta. And what is T that we found earlier? Mg cos theta. So if I place it here, mg divided by cos theta times sin theta. Can you tell me what is cos theta by sin theta? Tan theta, right? So eventually you get this mg tan theta. And you'll find this show up many times in your syllabus, a relationship. So your centripetal force here is equal to mg tan theta. Okay, so that's the equation for my centripetal force. Fc equals to mg tan theta. Now we're going to use this to find our answer. Okay, a part যেমন exam even if you don't show, it's fine, but obviously how else will you find it, right? So you have to somehow come to this answer. So show korteo paro, problem nai, but this is where we start our question. I want to find speed, right? So how do I find my centripetal force? So what's the formula for centripetal force? No, এটা তো এখানে আসছে, but what is the circular motion version of centripetal force? mv squared by r or m omega square r? I will use mv squared by r, because I'm trying to find what here? V. So Fc is equal to mv squared by r, and that is equal to mg tan theta. What cancels out? This is extremely important observation here. The mass cancels out. And do you know what the implication of that is if the mass cancels out? Yeah, there's no effect of mass. So if you had a bob here, which is lighter or heavier, right? How would the rotation change? It wouldn't change. Okay, so the rotation that takes place here is independent of mass. What I mean by that is, if you look at this previous example here, do you see there's a slider that says mass 1 kilogram? What will happen to the rotation if I increase my mass? Students think that it will fall down. No, that's what. It's same. Do you see it's a heavier mass and it still stays the same place? If it's a lighter mass, right, it will still stay the same place. Why? Rotation is not factored by the mass because mass cancels out in the equation. Okay, so this is something you need to know. No, just horizontal. So in vertical, the weight becomes an issue. So in this case, independent of mass, independent of mass. Right. Anyways, that's a side note. I'm for accurable. So this is v square by r equals to g tan theta, and that's it. It is all fully answered to way. But there's a small issue. I'll tell you what the small issue is. V square equals to g is 9.81 into tan is how much? 30 into r. What is the radius? Yeah, it's not 2 actually, because there's a small triangle there, and a triangular 8 2 meter. This is 30 degree. Is my circle of radius 2 meter, or is it the distance at the bottom here? That's my radius. Yeah, so it's a which shouldn't be an issue for you. What would you use here? Sine 30 equals to r by 2. So therefore, r equals to how much? 1 meter. So you can have 1 jabe. And once you solve this, data answer is the answer. How much is it? 2 point? Yeah. That's how you solve it. It may seem a lot of steps out there, but steps will beshi mone hobe tumi na bujhe thako. If you actually understand, you'll realize that I have written a lot of steps just to make you explain what's going on here. Right, so since this is in equilibrium vertically, T cos theta equals to mg, which is the weight. And this one is your what force? Fc? Resultant, because there's only one force horizontally. And independent of mass, which means yeah, the only force acting towards the center. Third law. No, it's on the rope, not on the bob. Independent of mass, which means mass has no effect. We will revisit this exact diagram again in another chapter called oscillations. We have a chapter called oscillations. So in same unit details a FC equals to mg tan theta is needed again. That's all this up. Yes. আমি সাথে থেকে টেবিলে দিয়ে দিচ্ছি না তোমাদের জন্য রিকোয়েস্ট শুধুমাত্র যেন নষ্ট না করো পরের রেজাল্ট তার জন্য কারণ আমি যদি শুধু করে বসে আমরা নিতে পারি না নিতে পরে কাজ হয়ে যায় আর আমি টিকা দিলাম না মশলাটা দিলাম না আর সিস্টেমে যায় নষ্ট হয়ে যায়
আরেকটা জিনিস এইখানে দিলে তুলতে পারবা সামনে এসে করতে তোমরা একটু কমফোর্টেবল হয়ে খাইতে পারবা আর কোনো অসুবিধা না থাকলে সামনে
It's for your AS exams. I mean, তোমাদের AS এর কোনো treat দিতে পারি নাই, so that's why. I don't know how your exams were, whether it deserves a treat or not. আমি দুই একটা কথা বলি, যদিও কোন সময় আমার এভাবে তোমরা অ্যাক্টিভ পাও না, যেটা হলো একটু খেয়াল করতে, আমি যেটা চাই এখন তোমরা 12 এ আছো, আননেসেসারি তোমরা যেন শুধু শুধু অনলাইন ক্লাস না করো, সবার ফ্রি করো, বিকজ অফ ইটস ভেরি টাফ না। ফিজিক্যালি আসলে যেটা হয় কম্পিটিশনটা বোঝা যায়, লেখাপড়া হয়, একটা এনগেজমেন্টও সুন্দর থাকে, কে কি করতেছে সেটা দেখতেছে সবকিছু। আমার মনে হয় কোনো না কোনো ভাবে এটার মধ্যে কোনো না কোনো পজিটিভ সাইড আছে। কারণ যদি অনলাইন ক্লাস দরকার পড়ে আমাকে বললে আমি সেটা সেট করে দিব, কিন্তু সেটা যেন কোনো না খাওয়া দাওয়া করার কথা শুনতে তো লস হয়ে যাবে, তাইতে থাকো আর আমার কথা শুনতে থাকো। এই গেল ক্লাস। সেকেন্ড হলো তোমরা সবচেয়ে সিনিয়র এমএসটিতে, ঠিক না? এমএসটিতে এখন কিন্তু খেয়াল করে দেখো অনেক গ্যাদারিংটা অনেক বেশি, সব ক্লাসের মধ্যেই অনেক গ্যাদারিংটা বেশি। এখানে ওয়েটিং এ সামনে অনেক লোকজন থাকে, স্টুডেন্টরা থাকে, যারা তোমাদের সবাই জুনিয়র কোনো না কোনো স্কুলে নাও না, যাদের যেখানে বেশি লাগে বলো, এখানে সবাই যেন একটু চুপচাপ থাকি, একটু হইচই না করি। ছোট ভাইরা বোনরা যদি করে তাদেরকে যেন বলি যে চুপচাপ থাকার জন্য। আর বাকি সব ডিসিপ্লিন তোমরা তো জানোই সবকিছু, হ্যাঁ। আর টেস্টগুলো সবাই অন টাইমে দাও, কারণ এই বছর যেটা চিন্তা করছি টেস্টগুলো নেওয়ার পরে এটা ডিসকাস করার পর আমি মার্কশিটও রেডি রাখবো, জাস্ট এটা ট্র্যাক থাকার জন্য আর কি, কে কিরকম করতেছো না করতেছো। আমি চাই তোমরা যে সাবজেক্টে আমি সেটা করতেছো সেটা যেন টপ লেভেল অফ রেজাল্ট করো, এবং তোমাদের সিনিয়ররা যেমন ওয়ার্ল্ডের অনেক বড় বড় জায়গায় আছে, অনেক ভালো করতেছে, তোমরা যেন সেরকম যাও, ঠিক না? আর এজ ওয়েল এজ অ্যাডমিশন ফর্মে যেগুলো লেখা আছে, কেউ বাইরের খাবার টাবার তোমাদের কিছু বলার তো নাই, নিয়ে আসা যায় না, দুষ্টামি করা যায় না, সেগুলো তোমরা খেয়াল রাখবে। আর নিয়ে নাও, এই যে এটা আরেকটা আছে, এই টিভিটা লাগাই সেগুলো নিয়ে নাও। কোথায় বেশি লাগে, যারা বেশি খাইতে যাও শেষ করে সবাই রবিন করো। পানিটা বয়েল করা পানি কেউ খাইতে গেলে কোনো সমস্যা নেই, কিছু বাইরে রাখা আছে, ঠিক আছে না? আর রিকোয়েস্ট করবো শেষ করার পরে একটু উঠায় বলা করে একবারে ক্লাসটা কিন্তু আমাদের হইতে হবে। আর মাসে একবার দুইবার একবার তো মিনিমাম কি করা চলবে। কন্টিনিউয়াসলি যখন অনেক গ্যাদারিং থাকে, আমার কোন টাইমের মধ্যে সব শেষ করতে হবে, যার জন্য আমি নিজেই করব ইয়া রিয়ালাইজ করতেছি। লাস্ট ইয়ার গুলোতে খায়া দেওয়া যায় না, শুধুমাত্র প্ল্যান করতে পারে না, আমি অর্গানাইজ করতে। এখন যেটা চিন্তা করছি প্রত্যেক ক্লাসে হয়তো এই টাইমের মধ্যে দিয়ে দিই, ক্লাসের মধ্যে আমরা ঠিক করে নিয়ে যেতে পারি, ঠিক না? তাদের জন্য তোমাদের সবার কোঅপারেশন দরকার, যেন আমার ক্লাসরুম নষ্ট না হয়, ঠিক আছে? উঠায় বলা দিতে দাও, তোমরা সবচেয়ে সিনিয়র।
बस आते हैं আমি অর্গানাইজ বেশি করে করতে পারতেছ না যারা বেশি খাইতে পারে এখানে পাস করে দাও সমস্যা নাই আচ্ছা সমস্যা নাই খাও স্যার ঠিক আছে তোমরা হবে 9 এর একটা বাচ্চা তো সাউথ দিয়ে মাস্টার বানায় 12 পিস থেকে ঠিক না একটা টেবিলের মধ্যে একটা নিয়ে আসো ঠিক আছে এটা নিয়ে স্যার দাও যারা নিতে চায় কিন্তু যারা নিতে না পাওয়া সামনে না পাঠায় নিয়ে দিতে পারবে কি
তো মনে হয় পারতেছে না কেউ what happened to you guys class grade 9 স্টুডেন্টরা হচ্ছে 12-13টা বক্স খেয়ে ফেলে robbing I think yeah there was this guy who ate a whole box of it I think so mastermind yeah maybe ও হচ্ছে নিজে বক্স খেতে পারবে না বক্স হাতে yes